Hello, my name is Daniel, and today we will be doing the AMC 10B from the year 2002. So let's get started. For our first problem, the ratio 2 to the 2001st power times 3 to the 2003rd power over 6 to the 2002nd power is, so let's separate 6 to the 2002nd power into 2s and 3s, 2 to the 2001 times 3 to the 2003 over 2 to the 2002 times 3 to the 2002 equals 2 under 3. This is E. For problem number 2, for the non-zero numbers a, b, and c, define a, b, c equals abc over a plus b plus c. Find 2, 4, 6. So let's just plug in 2, 4, 6 right here, and then we should be able to get 2 times 4 times 6 over 2 plus 4 plus 6. So it's 48 over 12, which is 4. It's C. Problem number 3, the arithmetic mean of the 9 numbers in the set. This is a 9-digit number m, all of whose digits are distinct. Then the number m does not contain the digit. Okay, so the arithmetic mean of these would be 9 plus 99 plus 999 plus all the way to 1, 2, 3, 4, 5, 6, 7, 8, 9. This divided by 9 since there are 9 numbers, so it's just 1, 2, 3, 4. So do that. Multiply and divide each one individually by 9. This is 1 plus 11 plus 1, 11 plus 1, 1, 1, 1 plus 1, 1, 1, 1, 1 plus all the way to 1, 1, 1, 1, 1, 1, 1, 1, 1. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and the only digit that is missing here is 0, so it is A. Problem number 4, what is the value of this thing? So the important thing here is to see that this and this, so they are distinct, right? So this would be 3x minus 2 times, and then this, we add these two, times 1, and then plus 1, which is 3x minus 2 plus 1, which is 3x minus 1, and x minus 4, this would be 11, this would be D. So it's D. Problem number 5, find the area of the shaded region. So they're externally tangent, and so the diameter is 3 plus 2 plus 3 plus 2 is 10, so the radius of the whole thing, that would be 5. And so the area of the shaded region would be 5 squared minus 3 squared minus 2 squared, and then we have a pi. So it's 25 minus 9 minus 4 times pi, so this is 12. Yes, this is 12 pi. So it's E. And then problem number 6, for how many positive integers n is n squared minus 3n plus 2 a prime number? So n squared minus 3n plus 2. This would be minus 2 minus 1. So n minus 1, n minus 2 is a prime number. So if n is a positive integer, then n minus 1 would surely, then from out of these two, 1 would be even, and one would be odd, right? And so if you multiply these two, these will have to be an even number. But for it to be a prime number, then it can only possibly be 2. And since n is a positive integer, the only possible answer is that n equals 3, so that this is 2 times 1. So there is only one positive integer where n squared minus 3 and plus 2 is a prime number. Therefore, the answer is B, 1. Problem number 7, let n be a positive integer such that 1 over 2 plus 1 over 3 plus 1 over 7 plus 1 over n is an integer. Which of the following statements is not true? Okay, so let's try putting these into one single denominator. 42 and then 21 plus 14 plus 6 plus 1 over n. This would be 42 over 41 plus 1 over n. So for this to be an integer, n would be 42. So n divides by 2, divides by 3, divides by 6, and divides by 7, but it is less than 84, so the answer is E. Problem 8, suppose July of year n has 5 Mondays. Which of the following must occur 5 times in the August of year n? Okay, so Both months have 31 days, and so July has 5 Mondays, and since there are at least 28 days in each month, there should be at least 4 full weekdays, and then we get to decide Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then we get to decide how does the combination have 5 Mondays. So this is clear, and do we have 2 more here, or do we have 1 here and 1 here, or do we have both here? So which of the following must occur 5 times in the August of the year end? So following this is July, right? And then August, it must be, so August must also have at least 28, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? And so which of the following must occur 5 times? So if July decides to have its 3 extra days here, then August, then the 3 days of August would continue from here. Would continue from here to differentiate them. And if the August starts from here, then we can say that like this. Then the August could start from here, so it would be either these 3 or these 3. And if August decides to start from here and have nothing here, then August would start from here, so it would have these 3. And so the one day that always overlaps is this day, which is a Thursday. So the answer is Thursday, so it's D. Problem number 9, using the 8 letters A, M, O, S, and U, we can form 5-letter words. If these words are arranged in alphabetical order, the word USAMO occupies position. Okay, so U is the last letter, but then it has to become the first letter. So we must have gone through A something 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 something, M, and then 4 things, O 4 things, and S 4 things before we've got to U. And so how many ways for this are there? So there are 4, so it's 4 multiplied by, and then we have of the remaining things 4 times 3 times 2 times 1, so it's 4 factorial, which is 24. And then when we finally got to U, then the S, it's the 4th letter, so we would have gone through U A something something something, S something something something, and M something something something. No, not S, not yet. So A, M, and then we would gone through O something something, and then we'd have come to U S something something something, right? And so these 3, similarly, there are 3 ways to do these. So it's 3 multiplied by, and then 3 factorial. So 3 factorial, which is 6. So this is 18, and this is 24 times 4, 96. And then from here, it's the first word, A-M-O. So this is 1. So all of these, 96 plus 18 plus 1 equals 97 plus 18 equals 115. So it's D. Problem 10, suppose that A and B are non-zero real numbers and that the equation x squared plus x plus b equals 0 has solutions A and B. What is the pair A comma B? So A plus B would be equal to minus A, and AB would be equal to B, and so from here A would be equal to 1, and so 1 plus B equals minus 1, so B is 2. No, B is minus 2. And so A comma B is 1 comma minus 2, so that is C. Problem 11, the product of 3 consecutive positive integers is 8 times their sum. So what's the sum of their squares? So if there's A and a minus d and a plus d. Then the product of three consecutive positive integers is a times their sum. So a plus d, a minus d equals 8 times their sum is 3a. So get rid of the a squared minus d squared equals 24. So what is the sum of their squares? So a squared plus a squared minus 2d squared plus minus 2ad plus d squared plus a squared plus 2ad plus d squared. This is what we're trying to get. This is, we'll get rid of these two, and then 3a squared plus 2d squared. What is the sum of their squares? Okay, so a squared is 24 plus d squared, so if we put that in here, then it will be 5d squared plus 3 times 24, which is 72. So it's 5d squared plus 72, and then it's consecutive, right? So d should be 1, so it's 5 plus 72, which is 77, so it's B. Problem 12, for which of the following values of k does the equation x minus 1 over x minus 2 equals x minus k over x minus 6 have no solution for x? So for this to have no solution for x, then first let's cross multiply. X squared minus 7 x plus 6 equals x squared minus 2 plus k x plus 2k. And so cross out the x here. So 2 plus k minus 7 x, this is 2k, this is a k by the way. And so this is 2k minus 6, so x equals, so x would equal 2k minus 6 over k minus 5, and for x to have no solution, k must be 5, so it's 5, it's E. Problem 13, find the values of x such that 8xy minus 12y plus 2x minus 3 equals 0 is true for all values of y. Okay, so let's see, minus 12y plus 2x, so 2xy, no, so it's 8xy, right? 4x plus, no, it should be x minus 12, and then 8y, no, it will be 2x minus something, and then 6y, so and then 4y, so this would be 3, yes, and this would be 1, yeah, so this would be 0. So x equals 3 over 2, or y equals minus 1 over 4. So it's the values of x such that this is true for all values of y, so x has to be 3 over 2. So the answer is D. Problem number 14, the number 25 to the 64th power times 64 to the 25th power. This is 5 to the 128th power multiplied by 2 to the 6 times 25 is 50 times 3, 150th power. So this is the square of a positive integer n. This is n squared. So n would be 5 to the 64th power multiplied by 2 to the 75th power, which is 5 times 2 to the 64th power multiplied by 2 to the 11th power, which is 10 to the 64th power multiplied by 2 to the 11th power. The sum of the digits of n is, okay, so for the sum of the digits, then we don't have to care about this one, since all it will ever give is zeros. So we only have to consider 2 to the 11th power, which is 1024 times 2, so this is 2048. So 2 plus 4 plus 8 equals 14, so it's B. Problem number 15, the positive integers a, b, a minus b, and a plus b are all prime numbers. The sum of these 4 primes. Okay, so If they're all prime numbers, then A or B has to be 2, because that's the only way that these can be odd. So if A is 1, no, so if A is 2, then the only thing we can be for A minus B to be a positive number is B equals 1, but that's not possible since 1's not a prime number. So A is not 2, so we've got that B equals 2. So if B is 2, then A minus 2 and A plus 2 all have to be prime numbers. So we have to find 3 odd numbers, 3 odd consecutive numbers that are all primes. So you can see that 3, 5, and 7 are matching these conditions. So we can say that A minus 2 is 3, A is 5, and A plus 2 is 7. So the sum of these 4 primes would be A is 5, B is 2, A minus B is 3, A plus 2 is 7. The sum of these 4 primes would be 17. So 17 is prime, therefore the answer is E. Problem number 16, for how many integers n is n over 20 minus n the square of an integer? Okay, for how many integers n? So the maximum of n would be 19, and so maximum of n over 20 minus n would also be 19. So the only possible things that n over 20 minus n could be is 0 squared, 1 squared, 2 squared, 3 squared, or 4 squared. Okay, so first 0 squared. This is very easy. N just has to be 0. 1 squared, this is just this and this has to be the same, so n equals 10. That would make it 10 over 10. And 2 squared, this would have to be 4, so n equals 80 minus 4n, so n would equal 16, and n would equal 16. And so n equals 16. And for 3 squares to happen, then n would have to be, so since it's 3 squared, this should be 9. N equals 180 minus 10n minus 9n. So n equals 18. And 4 squared, this is 16, so n would have to be minus 16 n plus 32. So n would be 32 over 17, and that's not an integer. So 4 squared is out, so there are 4 integers. So its answer is 4D. Problem number 17, a regular octagon ABCDEFGH has sides of length 2. Find the area of ADG. Okay, so a regular octagon. Look like this. I make a very bad regular octagon. Like this. This is at least acceptable, I hope. This has sides of length 2, so this is to find the area of ADG. Let's label A, B, C, D, E, F, G, H. And so ADG. If we put in some lines, then it becomes clear that this is 2, since it's right here, and then since this is a 40, since this is a 45, 90 triangle, this is root 2, this is root 2, and so the area of ADG would be this triangle right here, correct? And so to find the area of ADG, this will be this line. So let's say that this point is point I. So it'll be AI multiplied by this line, so it's dg multiplied by 1/2. So this is AI is if this is 2, this is surely root 2, and this is same as here, so this is also root 2. So AI is 2 plus root 2 multiplied by dg. dg is this is 2, this is root 2, this is also root 2. So 2 plus 2 root 2 times 1/2. This is 2 plus root 2, and then put this here, and then we will get 1 plus root 2. This is 2 plus root 2 plus 2 root 2 plus 2 equals 4 plus 3 root 2, which is C. Problem 18. 4 distinct circles are drawn in a plane. What is the maximum number of points where at least 2 of the circles intersect? So there are 4 distinct circles where at least 2 of the circles intersect. So there are 4 distinct circles, and let's make it so that there are as many intersection points as possible. This is the way where there are as many intersection points as possible. So the maximum number of points are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the number is 12, it's D. Number 19. Suppose that AN is an arithmetic sequence with A1 plus A2 plus all the way to A100 is 100, and A101 to A102 to all the way to A200 is 200. Okay, so let's make A1 A plus D, A2 A plus 2D, all the way to A100 is A plus 100D. Okay, so 100A plus 1 to 100, so that's 200 100 times 101D. This is 100, and 200 will be this much, so it's 100A plus 101 to 200, so 2 times 200 times 201 minus 100 times 101 over 2D. This is 200. So if we subtract these two, then we would get 100 equals 20100 minus 100 times 101D. So this would be 10000 D, 10,000D. So D would be 1 over 100, which is 0.01. So it's C. Problem 20. Let A, B, and C be real numbers such that A minus 7B plus 8C equals 4 and 8A plus 4B minus C equals 7. Okay, so we have 3 unknown values, but we have only two equations. So this means that we can't solve for all the exact values, but we can only solve for the ratio. So let's just say that A equals 0. Okay, so if A equals 0, then this would be just C squared minus B squared, right? And then if A is 0, 8C minus 7B equals 4, and 4B minus C will equal 7. So 32B minus 8C equals 56. So 25B equals 52. No, it equals 60, right? So B is 12 over 5, which is 2.4. And so C would be 4B minus 7, which is 9.6 minus 7. This is 2.6. So B squared so C squared minus B squared, this is 2.6 square minus 2.4 square. This is 126 square is 4 times 13 squared minus 12 squared. This is 100 under 4 times 5 squared. This is 1, so the answer is 1, it's B. Problem 21. Andy's lawn has twice as much area as Beth's lawn and 3 times as much as Carlos's lawn. Carlos's lawnmower cuts half as fast as Beth's mower and 1/3 as fast as Andy's mower. If they all start to mow their lawns at the same time, who will finish first? Okay, so for this one, let's just say that like a certain value is the length of Andy's lawn, and a certain value is the length of like the speed the and a certain value is the speed that Carlos's lawnmower cuts. Okay, so let's say Andy has 6 square meters. And then Beth has 3 square meters because he has twice as much. And Carlos would have 2 square meters because he has 3 times as much. And Carlos's lawnmower cuts half as fast as Beth's mower and 1/3 as fast as Andy's mower. So if Andy's mower cuts 6 square meters per minute, then Carlos's would cut half as fast as so it would cut 1/3 as fast as Andy's mower, right? So it would cut 2 square meters per minute. And since this is half as fast as Beth's mower, Beth would cut 4 square meters per minute. So Andy would be done in 1 minute, Carlos would also be done in 1 minute, and Beth would be done in 3/4 of a minute. And so Beth is the fastest, therefore Beth will finish first. It's B. Problem number 22, let triangle XOY be a right angle triangle with M angle XOY equals 90. Let M and N be the midpoints of the legs OX and OY respectively, given XN equals 19 and YM equals 20. Find XY. Okay, so let's make a right triangle here. I can't seem to make a right triangle these days. Yes. So it would be a XOY would be 90 degrees, so XOY with this 90 degrees. And let M and N be the midpoints of the legs OX and OY respectively. So this is M, this is N, given XN equals 19 and YM equals 22. So this would be 19, this will be 22. Okay, so find XY. Let's say that if this is A and this is B, this is B, this is A, so XN, this much is 19, and MY is 22. So let's say 2A squared plus B squared equals 19 squared. A squared plus 2B squared equals 22 squared. So 4A squared plus B squared equals 19 squared. A squared plus 4B squared equals 22 squared. Find XY. So if we add these two together, then 5A squared plus 5B squared equals 19 squared plus 22 squared, so it's 121 times 4, 484, and yeah, 19, 81, 171, 19, 361, 845, this is 845, so A squared plus B squared equals 169. So XY would be square root 2A squared plus 2B squared. This is square root of 4A squared plus 4B squared. This is square root of 4 times A squared plus B squared is 169. This is root 2 squared times 13 squared. This is 2 times 13. This is 26. So it's B. Problem 23. Let AK be a sequence of integers such that A1 is 1 and AM plus N equals AM plus AN plus MN for all positive integers M and N, then A12 is. Okay, so let's just start from 1 and work our way to 12. So if A1 is 1, then A2 would be M and N would both be 1, right? So this would be 1 plus MN is 1. This is 3. A3 will be A1 plus 2 here. And so it will be A1, so it's 1 plus A2, this is 3, plus M times N, this is 2. A3 would equal 6. Then A6 would equal, for us to get A6, then we need 3 and a 3. Then this would be 3, and this would be A3, so it's 6, A3, so it's 6. M times N, this is 9, so it's 12 times 9, which is 21. And then A12. A12, this is a6 plus a6. So it's 21 plus 21 plus 36. 42 plus 36 equals 78. So the answer is 78, so it's D. Problem 24. Riders on a Ferris wheel travel in a circle in a vertical plane. A particular wheel has radius 20 feet and revolves at the constant rate of 1 revolution per minute. How many seconds does it take a rider to travel from the bottom of the wheel to a point 10 vertical feet above the bottom? So riders of a Ferris wheel, so they travel in a circle, right? And then it has a radius 20 feet. So this is 20 feet. And revolves at the constant rate of 1 revolution per minute. So 1 revolution, this is 1 circumference, right? So it's 40 pi per minute. So it says how many seconds, so let's make it into seconds. 40 pi per 60 seconds. How many seconds does it take a rider to travel from the bottom of the wheel to a point 10 vertical feet above the bottom? So it would be like about here, and this would be 10 vertical feet. And so for this to have altitude of 10 feet, then this thing is 20, right? Oh, so this would be a bit lower off. So this would be about halfway, and then the radius would be here. This would be 10, and if you draw a line here, this would be a right triangle. This here would be 10, and this would be 20. So this would be 10 root 3, and that means that this angle is 60 degrees. So 60 degrees is 1/6 of the circumference equals 1/6 of 60 seconds. This is 10 seconds. So we didn't even need this at all. So it's D. And our last problem of the day, problem 25. When 15 is appended to a list of integers, the mean is increased by 2. When 1 is appended to the enlarged list, the mean of the enlarged list is decreased by 1. How many integers were in the original list? Okay, so let's say if the list of integers has n integers, then if the mean, and if the original mean is a, so an plus 15 equals a plus 2 times n plus 1. And when 1 is appended to the enlarged list, so an plus 16, this becomes the mean of the enlarged list is decreased by 1, so it becomes a plus 1 now. And then it's n plus 2. This is an plus a plus 2n plus 2. This is an plus 2a plus n plus 2. So these are canceling. And here a plus 2n equals, a plus 2n equals 13. Here 2a plus n equals 14. And so a plus n equals 27, so it's 9. So n equals 4, a equals 5. So how many integers were in the original list? We are looking for n. So n is 4, therefore the answer is 4. So problem 25, the answer is A. So that was problem 25, and thank you for watching.